Hi, this is Saranya Chitala. Welcome to Easy BTech. Today in this class we are going to learn about another important topic is an flooding algorithm. So let us see what is meant by an flooding algorithm here. Uh, what is the procedure it follows and to find on best route from source to destination, right? Let us get into the topic. So flooding algorithm, the flooding algorithm is a non-adaptive routing technique. That means it uses an static routing algorithm. Static routing algorithm, I already said the routing algorithm can be divided into two types: static routing algorithm, dynamic routing algorithm. So here the static routing algorithm means it creates a best route before the data packet is transmitted to the network. It creates a route before the data packet transmitted to the network. That is a static routing. Here, whenever the network establishes, we find a best route. The routing information will be stored in all the routers. The routing information will be stored in all the routers in the network. Right. Here, the flooding algorithm uses an broadcasting. Broadcasting means it sends the data packets to all the nodes that connect to the network. It sends the data packet that all the nodes that connect to the network. Here, it uses an one simple method or simple technique. When a data packet arrives at a router, when a data packet arrives at a router, it is sent to all the outgoing links. I already said it sends the data packet to all the nodes that connected to the network, except except the one it has arrived on. What the one it has arrived on? That means wherever the particular node receives from the previous node, it does not, the reverse process will not done. Reverse process means that particular node will not send to the previous node whenever it attached to the link. Okay, here that is the process. We have a different types of flooding here: uncontrolled flooding, controlled flooding, selective flooding. Uncontrolled flooding. Uncontrolled flooding means here each router unconditionally transmits the incoming data packets to all its neighbors. Means where the different type of nodes connected to the particular type of network. Here all the data packets sends to all the nodes, right? So control flooding means we have to control this type of transmission by using a sequence number. So let us consider one example. We have a clear idea about this, how the data packet sends to all the nodes, how we can eliminate this type of uncontrolled flooding by using uncontrolled flooding, right? Okay, so let us see one example. So this is invisible, I hope. Here we have a one graph, right? So B, C, D, E, F, right? So these are the nodes in between the network. The A is an source, and D is an destination, right? D is an destination. We have to send a data packet from all the nodes. So here A is interlinked with B and E. So I send the data packet to B and E, and B is interlinked with B and E. These also receives an data packet. So all the nodes receives the data packets. Finally, the destination receives a duplicate data packets. Here, what is the drawback? What is the drawback means here all nodes have an one data packet, right? So we already set one particular best route. But here, wherever the different type of routers that connect the network, that also access the data packet. That is in broadcasting. This is the one of the drawback. Here, the destination receives and duplicate of data packets. Duplicate of data packets. To avoid this, to provide a security for each and every data packet, okay, we use an controlled flooding. We use an controlled flooding. Controlled flooding means here each and every packet provides an one sequence number, provides a sequence number. Okay, one sequence number. So whenever we provide a sequence number to each and every packet, we eliminate this kind of duplicate packets, right? Let us see this. Okay, I am drawing a graph again. Okay, this is the actual graph, and A is a source, D is a destination, right? A is a source and D is a destination, right? Okay, so here I have a data packet. I named it as an P1. This is a sequence number. This is a sequence number, right? Okay, I send this data packet to B and E. To B and E. Okay, so here B has an data packet P1 and E also has an data packet P1, right? Next, we can consider the B as a source node here. We have to pass this data packet to the next interlink nodes. Okay, from B we have a two interlink nodes, that is B to C, B to E, and also have a B to A. So here A has an two interlinked nodes B and E. I send the data packets to B and B also we have to see the interlinked nodes. So A, C, E, three nodes. A, C, E. I already said in the flooding. So whenever it receives a particular data packet from one node, the reverse process is not possible. Here the B receives a data packet from A. So it does not send again data packet reversely. So we cancel A here. Next interlinked nodes C and E. So the C does not have a data packet. It sends the data packet to C. Okay. The E has a data packet P1. So whenever data packets go to the E, it will checks it has a data packet, that particular data packet is there or not. So it receives a data packet from A. So it kindly ignore the B data packet. It kindly ignore the B data packet. Okay. So we ignore A and E here, and we have a data packet to C and E, right? Okay, so I send the data packet to P, right? So I will draw neatly again. For each and every step, we have to draw a graph because we'll get an confusion, will rise in confusion. Okay, so here C has a data packet P1 and E has a data packet P1. Right. So from A to B and E, okay, from B to it will send to C from A. Okay, right. So we have to see the next. The C will send this packet to the next interlinked nodes. Next interlinked nodes. So kindly find that. So the C is interlinked with B, F, and D. B, F, and D. So B is an from B it receives a data packet. So kindly ignore B. The reverse is not possible, right? Next F and D. So here these two nodes verify is there a packet receives from previous node or not, but it does not have a packet. So it sends a data packet to F and D, right? Okay. Next. D. D is a destination node. Next, D is a destination node. There is no interlinking nodes for D. So kindly ignore that. Next, we have a two nodes E and F. E. So E is interlinked with A, B, F. E is interlinked with A, B, F. Right. So it receives data packet from A, so kindly ignore that. B. So it does not receive data packet from B. So B doesn't have a data packet because it passed this data packet to the C, right? Okay, it sends it. Okay, P1, and kindly F. It also has already has the data packet, so it ignores that. Next, from F interlinked with E and C and D. Okay, I'll draw in a new manner. F, right? Okay, so we are seeing an F interlinked nodes, that is E, C, D, right? So E, C, D, right? We have a data packet currently D. Okay, so E. It does not receives data packet from E, and E also doesn't have a data packet because it sends to the B. So it accepts in data packet P1, right? Okay. So C means it receives a data packet previously from C. So kindly ignore that, and it sends the data packets to D. D also has a data packet P1 already have from C it receives. So kindly ignore that. Okay, so this is the process how we eliminate this duplicate of data packets from at the destination. The destination receives a data packet 1. Okay, there is no duplication of data packets here. There is no duplication of data packets here. So this is the procedure how we eliminate the duplicate data packets in flooding algorithm. We controlled this uncontrolled flooding, right? Okay, so we use method here. We use an algorithm here, means a sequence number control flooding and reverse path forwarding. So here we use an sequence number control flooding, and by using this algorithm we eliminate the duplication of packets. We give an security for each and every packet. So kindly only one packet will be received by a destination, and we also have a selective flooding. Selective flooding means the routers does not transmit incoming packets only along those paths which are heading towards approximately in the right direction instead of every available path. Here, the selective flooding does not transmit the incoming paths to all the incoming packets to all the those paths. It's only who are which are heading towards approximately, which are heading towards approximately in the right direction, means only one direction. For that parts only it gives an particular packet. That's why the names come and selective flooding. And these are the example of flooding. How the flooding uses a procedure, it uses an broadcasting. This is an uncontrolled flooding which uses an broadcasting technique, means that is nothing but an uncontrolled flooding. But we eliminate that broadcasting technique by using and control flooding algorithms, nothing but an sequence number control flooding. We use a sequence number control flooding in this example. So these are the different type of techniques and different type of floodings, and this is about a flooding algorithm. We discussed the different another distance vector flooding algorithm, this type of flooding algorithm in the later classes, right? Kindly like, share, subscribe Easy BTech for more videos. Thank you.